Hello, my name is Emily Blumenshine, and today I'm going to be talking about phonation, which is the process that allows us to produce voice. So, throughout this presentation, I will explain how our bodies create sound, what structures are involved, and why phonation is such an important part of speech and communication. As future SLPs, understanding phonation will help us recognize what happens when something isn't working properly and then how we can help. So, what exactly is phonation? Phonation happens when air from our lungs moves up through the larynx, also known as a voice box. So inside the larynx are the vocal folds, which vibrate as air passes through them. That vibration is what turns air into sound. It's literally how our voice is made. If you look at the image on the slide, you can see how air would travel up the lungs through the trachea and then reach the larynx, where sound begins. This process is the foundation for all voice sounds, like vowels and consonants such as B and G. And without phonation, our speech would simply be a whisper. Now let's look at the larynx, which can be seen in the diagram here. So the larynx has a big job, and it is made up of cartilage and muscle that include the thyroid, cricoid, and arytenoid cartilages, which can be seen in pink here. We have the thyroid cartilage, cricoid cartilage in yellow, and arytenoid cartilages in blue. And together, these structures hold the vocal folds and connect the airway to the vocal tract, which is the path that shapes the sound into speech. So the larynx also plays an important protective role. When we swallow, it closes off the airway so that food and drinks don't go into our lungs. So besides creating voice, it also keeps us safe while eating and drinking. The vocal folds shown here have two soft bands of tissue that stretch across the larynx, and they attach to the thyroid cartilage in the front and then the arytenoid cartilages in the back. So when we breathe, the folds open up, which is called abduction. And then when we speak, they close together or adduct to let air build underneath. That air pressure causes the folds to vibrate. And then the thyromuscularis muscle adjusts their tension while the thyrovocalis muscle helps control pitch, so we can speak in higher or lower tones. And then these folds are very flexible, and that allows us to make many different sounds. Okay. There are also several small muscles that help the folds move the right way. So in the diagram, you can see the lateral cricoarytenoid, which pulls the folds together, the transverse arytenoid, which slides them closer, and the oblique arytenoid, which tightens the closure. So these muscles all work together to keep vibration smooth and even. When everything is balanced, the voice sounds clear and steady. But when those muscles are overused or strained, the sound can become rough or more breathy. So this image on the right here will help explain what myoelastic aerodynamic theory is, and it will describe how phonation actually happens. So myo means muscle, elastic means the folds can stretch and bounce back, and then aerodynamic has to do with air pressure. So what happens is the muscles will bring the folds together, the air pressure will build up underneath them, and then that air pressure forces the folds apart. And then as air rushes through those, it will lower the pressure and the folds are pulled back together again. And then this cycle will happen hundreds of times every second, and that ultimately is what's creating vibration and sound. All right, in this slide, I'll go over subglottic pressure and the Bernoulli effect. So subglottal pressure builds up below the folds until it pushes them open. And then once the air escapes, the Bernoulli effect, which is kind of like suction, pulls them back together. So this process will repeat so quickly that it creates a steady wave of vibration. And that's the source of our voice. So when air pressure is strong and steady, the sound is clear. But if the air pressure is weak or uneven, the voice can sound breathy or shaky. All right. The air coming from our lungs is what powers our voice, and it's called the air column. So shown in the image, the stronger and more consistent the airflow, the clearer the sound. Air pressure also affects how loud or soft our voice is. So once the sound leaves the larynx, it travels through the pharynx, mouth, and nasal cavity. And these areas shape the sound into recognizable speech. That's why everyone's voice sounds a little different, and it depends on the shape of their vocal tract, which in the second image here is a good example of the phonation and the air needed from the lungs to push that consistent airflow up to create clear sound. So here's a visual that shows the difference between adduction and abduction. So during speech, the folds will adduct, meaning that they come together to vibrate and create sound. Then during breathing, they will abduct or move apart to let air pass freely. So these movements happen automatically and are controlled by the laryngeal muscles. It's an incredible system that adjusts instantly while we talk, breathe, and even pause mid-sentence. The next image shows the folds in motion, highlighting their elasticity. So the vocal folds can vibrate hundreds of times per second, higher when we sing or speak in a high pitch, and slower when we use a lower voice. So when the vibration is smooth and balanced, the sound comes out clear. But if one side moves different than the other, or if tension changes, the voice might sound rough, hoarse, or shaky even. So why does phonation matter? Phonation is what gives speech life, tone, and emotion. So the visual here shows that how it would make vowels and voice consonants like B, D, and G. And it also is how we express our feelings. So our voice can change when we're happy, calm, tired, or upset. Without phonation, our words would sound flat and robotic. And it is what makes speech sound human and more expressive. So what happens when phonation goes wrong? So sometimes phonation does not work properly. And this is an example shown here where there's vocal fold paralysis, which is one type of voice disorder. And there's other common issues such as nodules, swelling. These problems stop the folds from vibrating evenly, which can make the voice sound weak, rough, or breathy. So as SLPs, we can help by teaching clients healthy voice habits, good breath support, and safe speaking techniques to get smoother, more natural vibration. All right. Keeping a healthy voice really starts with small habits. So you can see that staying hydrated is important. And this will keep the folds soft and flexible. Having good posture can help airflow move smoothly. It is also important to avoid yelling, whispering too much, or clearing your throat a lot, since those can irritate the tissue. And we also need to think about cultural and lifestyle differences when giving advice. So not everyone uses their voice in the same way. So our recommendation should also fit into each person's daily life and background. All right. These were the sources that I used. So the ones on the left are the main sources I used, including the textbook of Anatomy and Physiology for Speech, Language, and Hearing, and then two journals I found in the GCU library. And then on the right, I did not use those for any of my writing or research. I simply used those for my images. Um, so together, these explain how phonation work, why it's essential for speech, and how SLPs can help clients use their voice safely and effectively. Thank you for listening.